All right, so we're back. This is the second break session of the first Cipher. And yeah, let's hop into it. So this figured going to go over some pretty, what I think is cool technology that's kind of coming to like the web, which is amazing because the web is always growing and getting better, you know, as technology and thing moves on. Like it doesn't stay stagnant, which is cool. Well, unless you want things to stay the same, so you never have to learn anything ever again. But maybe this is not where you want to be. You know what I mean? It's because it's always, which is what I like, because I believe it's getting better. And I want to show something that I think is the case, makes the case. All right. So I am going to share my screen and then I'm going to need audio because I want to show a video. Excuse me. All right. I can see my internet is going terribly. That is great. All right. So let us go ahead and get this started. All right. Before my internet cuts out, which will probably happen. Okay. So sharing the screen, share audio. Great. Here we go. All right. So now I'm a big fan of like not repeating myself, like not writing the same code over and over again, especially if it's something that I'm going to be needing a lot. So as example, right here on this very website, like if you go to untilit.works/about, and I'm going to copy and paste this so that the links will be along with the recorded video, so you can always check it out. But if you go there, you will notice this thing here. Now, this is a web component, right? And I think I can just view, let me inspect. Let's see here. So yeah, so here's the web component, and it's called Dwayne-made. And I make a lot of random projects. And so instead of creating an about page over and over again with the details of the website, I figured this would be a good case to create a web component so that I can just plop that into the site and then it would just automatically work. So what's happening is that the Dwayne-made, you can pass in the URL to an endpoint that will fill out these certain sections of the site, of the web component, so that like the about is specific for every the about is specific for every side project I make. Same thing with the built with, because I make things with different technologies. And then the different updates, if there's any updates. So all of that comes packaged just in that web component, which I think is pretty cool and a reason why I like it. Now, the thing is that to use this in the head tag, so I need, because the browser doesn't understand Dwayne-made. It understands like H1, P tags, A tags, you know, things like that. So for it to be able to understand what Dwayne-made is, we have to include some JavaScript, right? And so as you can see here, oh, and this is for another one I have, the timer. That's another web component. But so as you can see, so there's like normally like two script tags that I need. One that says, hey, what a web component is to the browser kind of thing. So that it's like, okay, cool. And so, and then also the JavaScript that comes across where it's like, where the browser comes across this thing. First is like, oh, there's this thing called web component. Come across Dwayne-made. Oh, must be a web component. And then it goes to the JavaScript to handle all the rendering and stuff so that everything comes out the way it should. Cool. So now the thing is, there's not much interactivity with this. This is pretty much static, right? None of this stuff changes, doesn't need to be changing like real time or anything, right? So it's basically making a call to an endpoint, getting the data and filling out the spots. So you can pretty much say it's static, right? So, but the thing is, you still need the JavaScript to be able to render it properly because, and this is what we're going to talk about, there's really no good way of rendering web components on the server, because what would be cool is that send a request to the page sees like, oh, there's this web component, let me render this web component on the server and then just send down just regular HTML, right? Because that's pretty much what all this is. If you go and look at the inside, as you see, is just regular, just HTML inside of the shadow root, which we'll talk about. So yeah, so you see it's just regular HTML, nothing, no JavaScript needed, right? But you need JavaScript to render it because it's a web component. So there have been ways to get server-side rendering of web components. And so some folks that I've used before, right here. So this is Stencil, and I've used Stencil before to make web components. Matter of fact, I think the Dwayne-made was created using Stencil, if I remember correctly. All right, so because this is a while ago I did it. So now Stencil has a way of being able to do server-side rendering of web components. And so what it does, so let me post a link to here. So this kind of talks about how it handles server-side rendering, right? So right here, all right. So server-side rendering is the process of rendering content to a client based on an HTTP request. A client makes a request and the server processes it, returning rendered HTML back to the client. Now the client then hydrates that HTML and bootstraps the client-side JS app. And so that's the way they're thinking about doing it. So they render it out on the server, and then they ship down the HTML down to the client. And then if it needs any JavaScript or anything, hydration, they'll do that on the client side. That's the only place you can do it. All right, and then you can also do static site generation. So now they mention that if a page simply must be, because they talk about the limits and stuff here too, so it's good reading. That's why I posted a link. If a page simply must be server-side rendered, then that can be done using Stencil's hydration functionality in any Node.js-based server. Cool. So again, this is Node-based. All right, so that link takes you to the Hydrate app. Let me post a link to this as well. Great. So now the Hydrate app, what this basically is doing is is a bundle of your same components, but compiled so they can be hydrated on a Node.js server. So they do stuff to the code, to your components, so that it can be hydrated on a Node.js server. This is the same Node.js app, which pre-rendering uses internally, and because you can pre-render them, which is pretty cool. And the same one which Angular Universal SSR, because Angular can also create server-side rendered apps. Uses for Ionic. Cool. Now, like Stencil components, the Hydrate app itself is not restricted to one framework. So you can use it like Vue, React, what have you. Cool. Now, note, the Stencil does not use Puppeteer for server-side rendering or pre-rendering, because I guess, so Stencil has their Hydrate app that does stuff. But another way of getting the like a web component to be server-side rendered is to pretty much, all right, you call your site in something like Puppeteer, which will basically open up a browser and then render it. Then you get that HTML and then you send that back to the client, which is kind of be cumbersome because you're like opening up another browser thing like on the server, rendering it. Because the thing is, in order to do a lot of this stuff, you need access to like the window and DOM, but you don't have that on the server. So that's why you would need to previously to open up like something like Puppeteer, which is like a headless Chrome browser. And so you have to install that, run that on your server, all these things. It's a lot of stuff. Cool. But now, right, so I've been working, I'm creating a side project, and I'm using Astro, which is something I've been looking into. Cool. Real quick, Astro is a framework that helps kind of like ship less JavaScript to the client. So what it'll do is it'll do some rendering stuff on its own, like when it's compiling or whatever, and then ship that stuff with the least amount of JavaScript that's possible, right? And so now you can ship it with JavaScript as well. You just have to state that you want it to be rendered with JavaScript, pretty much, that it needs to be interactive. Otherwise, it's just going to ship the HTML, won't be interactive. But they have certain like attributes that you can add on for certain things. It's kind of cool. So let me post a link to this blog post because this has what I'm going to be talking about. Now, so Astro, so the way Astro works is that you can use Vue, React, Lit, and Svelte with it. So if you want to have some, if you're familiar with any of those and you want to have components, like you can build your components using the framework that you like, because, and I think it has solid JS also. Yeah, solid support. So that came out also. But what's cool is that you can take your favorite like framework that you like, well, if it's supported, and then Astro has renderers for those. So if you write something, like I've been writing something in Svelte, what happens is now you tell it, hey, I'm using Svelte, right? And so it will use the Svelte renderer to render the component so that it's just HTML on the when it's shipped down to the client. And if you want to have interactivity, then you can ship also that renderer to it so that you can hydrate the application so it's interactive. Now, for my use, my web component, so that's cool if you're building a Svelte, but what if you have like a web component that you built already that you wanted to use? So now the thing is with Lit just came out with a new version, Lit 2.0. And with that comes some server-side rendering goodness, right? And so Astro now has support for it, and part of that is the Lit renderer for Astro. Cool. Now the thing is, the Lit renderer for server-side rendering of web components uses the new thing, the Declarative Shadow Dom. So let's talk about the Declarative Shadow Dom because that's kind of fascinating. I'm going to post a link to web.dev. Now, you have to understand my understanding of this is super shallow. I'm going to dive into it more once I get into actually creating a web component where I need it to be server-side rendered. But for right now, just kind of like there's some of the things that I found, which I thought was kind of cool, and just sort of talking about it here, is as I understand it. So yeah, so it's Declarative Shadow Dom as I understand it. So here, shouts to Jason Miller and Mason Freed for the article at web.dev. Again, I posted a link to it in the video archive, so you can go right to it. So now they're saying how Shadow Dom is one of the 3 web component standards. Yes. So when you're making and it's funny because I just like wrote a blog post for work about it because it helps. What the Shadow Dom does, it helps encapsulate all the stuff that's inside of the web component, so that things on the surrounding application can't really interfere too much, like with things like the styling or changing functions or anything like that, because you want your web component to be like self-reliant. Like you put it on the page, it knows what to do, it's going to do what it does, right? Cool. So that's the Shadow Dom in a nutshell, basically. Now, my blog post that's coming out is talking about how you can change those styles if you want. Like if you know what I mean? So you have free reign of how you want to create your web component. And if you want like the person using it to be able to do things and change things to maybe suit and customize for their own need, for their own application, you can do that as well, which is cool. So all that to say that now the Shadow Dom provides a way to scope CSS styles to a specific DOM subtree and isolate the subtree from the rest of the document. Basically, a better way of saying what I just said. All right, cool. Then talk about the slot element. Now, so the thing is, until now, the only way to use Shadow Dom was to construct a shadow root using JavaScript. But then the thing is that you see here, you need the document.getElement by ID. So you get it. And then you attach a shadow root to it. And then you put in what you want into that shadow root. So within your web component, I like to think of it as like your own like little shadow realm, or like your own little like pocket galaxy or what have you. And there you do your business, do what you got to do. And if you want, you can send out messages and you can receive messages, all that stuff. But the thing is, it's like it's your own little space that you can control, right? Now, the thing is, to be able to do anything with that space, previously you needed to do it with JavaScript, which meant it had to be done on the client because you can't really do that because you don't have access to the document because there is no document on the server side. There is no DOM, right, on the server. So it goes on to say, and it's way better than I can say it, an imperative API like this works fine for client-side rendering. The same JavaScript modules that define our custom elements also create their shadow roots and set their content, which is what's happening here. However, many web applications need to render content server-side to static HTML at build time, right? So as you're making it or whatever is being requested, you need to have that. This can be an important this can be an important part of delivering a reasonable experience to visitors who may not be capable of running JavaScript. Because again, my about section, you shouldn't need JavaScript to run it, just to show the information that's coming from a server, right? So now the justifications for server-side rendering SSR vary from project to project, which again, just know your use case and figure out whether or not you want to use this. Some websites must provide fully functional server-rendered HTML in order to meet accessibility guidelines. Others choose to deliver a baseline no JavaScript experience as a way to guarantee good performance on slow connections or devices. And that's why I'm looking into building Astro, because this next side project is pretty much just going to be able to run locally. You won't really need to use the internet really. You should be able to run it locally. And so I want it to load as quickly as possible. And so I don't there's pages where you don't need any JavaScript. So I'm using Astro to be able to, tell it, hey, I want JavaScript on this part, but I don't want JavaScript on this thing. And it all in one place. You know what I'm saying? So, and it handles that for me, which is great. Cool. So goes on to say that the justifications, let me make sure. Okay. So slow connections of devices. Now, historically, it has been difficult to use Shadow DOM in combination with server-side rendering because there is no built-in way to express shadow roots in the server-generated HTML, right? So on the server, while it's generating it, since you don't have a document to attach things to, you're kind of difficult to be able to add the shadow root and all these things and then put it in the content. All right. So previously, like I said, you'd have to maybe run Puppeteer or use the Hydrate app from Stencil to get that stuff working. So you can have kind of like a DOM that you can do all those things to get that HTML and then ship it down. So like it says here, there are also performance implications when attaching shadow roots to DOM elements that have already been rendered without them. So it, doing a lot of stuff. This can cause layout shifting after the page has been loaded or temporarily show a flash of unstyled flash of unstyled content while loading the shadow roots style sheets. Cool. So that is where the Declarative Shadow Dom, DSD, removes this limitation, bringing Shadow Dom to the server. So all that stuff, all the things in the past, we you can't really do this. Now with Declarative Shadow Dom, you can, which is kind of amazing. All right, cool. So go on and say, so building a declarative shadow root. So what happens is a declarative shadow root is a template element with a shadow root attribute. So now remember, when you're trying to do all this stuff here, see right here. So notice shadow root mode open, right? So you're getting the element, then you're attaching the shadow DOM, the shadow root mode open. So look at that. And then you're adding this inner HTML. Cool. So now that's imperative, but now declaratively you can do, so here's the host element. You could be your my awesome component or whatever here. And see, again, the shadow root open. So we're not using JavaScript to add this part. We're doing it declaratively. We're just saying, here you go. And now it will be understood by the server or what have you. Or yeah, when it does what it got to do. All right. Again, this is my surface level of just kind of looking over this, what's going to happen. So now a template element with shadow root attribute is detected by the HTML parser on the server and immediately applied as a shadow root of its parent element, right? So same way, so you see, so now you see this here, the host element, the declarative part turns into this, which is what's understood by the browser. Great. So now, yeah, and immediately applied as the shadow root of its parent element. So that's what this is talking about. Loading the pure HTML markup from the above sample results in the following DOM tree. So this is what the browser gets. And so all that kind of awesome. It goes into more stuff. You can do a lot of things. It's pretty cool. Now, so the good folks at Lit then took all this knowledge that's here and wrapped it into their rendering with anything built with like Lit. I think they have it to where other things can use it as well. Don't quote me on that, but I think. And so a few months ago, when they announced the beta launch of it, they kind of went over the SSR stuff. So this is a little bit of the actual presentation. And so let me, shouts to Kevin Schaff. Let me add this to the list of links so you can check that out later. All right, so we're going to listen to a little bit. Now he's going to show the part. Let me go back a little bit because he talks about, from what's on the server, and then some things will look hopefully familiar to you. What's going on? Okay, hold on. Here you go.
And that will get rendered out to the client.
So that's on the server, right? What's happening? And then it's going to get rendered. So it's going to show what gets rendered to the client. So it does what it's got to do, and then we'll see right here.
Now, since we deeply rendered these elements that were in the template on the server, we'll actually string the following HTML to the client. So this is sort of the fully exploded contents of those elements.
So you see Declarative Shadow Dom right there. And we've just been talking about that. Kind of cool. So that's the stuff that comes out of it. So on the server, Lit is doing all that stuff that we just went over from the web.dev thing, and it's shipping that. So you notice it says template shadow root open. See how things fit together? I love when stuff like that just like clicks for me. All right, go on to say. Sorry to interrupt you, Kevin. Here you go.
And I'll pause here for a second and note that Lit SSR takes advantage of a new browser feature called Declarative Shadow Dom, which is working its way through the standards and is already usable on Chrome 90, released just last week. So we're aligning our SSR offering to this new proposal, Declarative Shadow Dom. And in a nutshell, it's a simple new feature added to the browser that adds a shadow root attribute to the template element. And then when the browser parses a template shadow root, it's going to automatically create a shadow root on its parent and immediately move the contents of that template into it. So using this template shadow root, we can have full fidelity initial paint using Shadow Dom for server rendered components with no JavaScript whatsoever.
So you saw that, right? So what happened there is that, so on the server, you basically create this, right? And then you ship that down to the browser. And now because of the declarative, so this is just HTML, right? So you create it. So you take your component and whatever you build it in, somehow turn it into this. And this is what Lit is doing for you on the server while it's being rendered. So it does this, takes your component, and since it's built with Lit, it understands how to turn it into this. So whatever you're using, make it look similar to this, basically, right? And so then from there, that gets shipped to the browser. And then the browser's like, oh, I understand this because I know this about this thing called the Declarative Shadow Dom. And then it will take it, and then when it's parsing it on the browser, like when it's showing your page, it will go ahead and do what it needs to do so that it works. And it just understands it. Just like how my about, so if you notice, like my about here, how did that get up there? Let me move this down. So you notice, like when it's rendered on the page, my Dwayne-made, you see has a shadow root thing here, and then it just has the HTML inside. And that's what's happening. So because the browser created this, right? And so that's what's happening here. So it gets this, and then the browser using the shadow declarative DOM is like, oh, I understand this now, and makes it like this. So it just renders properly. And I think that's pretty cool. I think that's super awesome. And yeah, that's it. So I guess I'll let him talk a little bit more and finish up. So again, this is pretty cool.
Initial paint using Shadow Dom for server rendered components with no JavaScript whatsoever. And then for browsers that haven't yet shipped the Declarative Shadow Dom feature, there's a tiny polyfill that you can load to turn template shadow root elements into real Shadow Dom, similar to the native feature, still without needing to load any custom element definitions and get most of the same benefits from the server rendering. Okay, so with just the server rendered HTML, we can get a full fidelity initial paint of the content with no JavaScript. However, just like with any SSR solution, in order for the page to actually become interactive, we'll eventually need to load JavaScript. And if what you're rendering is
so then again, so like for my example, I don't need it because like the about there is no interactivity. It's just presentational. Like, here you go. Now, if you wanted to add some interactivity, so now what's cool is all this just HTML, so it loads quickly. And then you can load some JavaScript if you want it to be interactive. And that's what they do here. So yeah, so that's where the experimental Hydrate support comes from. And then your actual component stuff there. And yeah, so that's it. And so you can check out the full video, a lot of good stuff. And yeah. And then they just recently also just had a whole nother one. So their YouTube channel. See, they just announced. So that one was the beta release. But now Lit 2.0 is officially announced. It came out like 2 weeks ago. And so all that server-side rendering stuff is in there. And yeah, pretty awesome. So cool. So yeah, that's where I'm at with it. That again, that is, as I understand it, Declarative Shadow Dom and how I plan on using it. Let me stop sharing my screen. And yeah, so thank you all again for hanging out. Hopefully it didn't confuse you too much, I hope. And that maybe you can see, my hope is that you can see how maybe you can use it in your projects. And just to let you know that there is such a thing that's out there for you to take advantage of and help you build a quicker website for folks, because that's what I'm into as well. So yeah. So again, so I'm hoping that with the, I'm almost almost done with the new side project. So I want to get that done soon. And then maybe I'll show it on here and kind of show some of the stuff that I built with Astro and things. So, and then if I need to build anything, if I need to do like another web component that I use a lot, maybe I'll do it in Lit. So that way I can use it in Astro and have it server-side rendered to check that out. I'm not sure, but what I did was I like the Dwayne dash made. I just recreated in Astro and it just did it. It was just pretty quick and easy. But if there's anything else, I'll probably use like Lit or something. All right, all that to say, I'm gonna get y'all back to work. I thought this was pretty cool. Hopefully you think it's cool as well, and that you want to go and check it out. All right, so I'm not trying to mess this up, so I'm taking my time because I would really hate to have to redo all this. Okay, cool. I'm setting it now. I'm being very, very careful. All right, so I'm going to get y'all back to work. Again, thanks for hanging out. I know this one went a little bit long, but I'm going to give even more time for the final work session. And yeah, cool. Hope you are getting what you need done. Appreciate y'all. And yeah, see y'all later. Thanks again. Oh, I almost forgot to create the highlight video. Oh, that would have been bad. Would have been upset. All right, cool. Thank you all. Share my screen. All right, share my audio. This here. Cool. And now this is Anthony Cruz, aka A Butta. The track is called Thank You. All right. So much productivity for you, and see you 15 minutes after the hour for the final break session, and probably go over an artist's website or something so we can kind of check it out. All right. Thanks again, y'all. See you soon. Be easy. Peace.
I want to say thank you for holding on when a brother was down and out. Now I feel so strong, and I want to say thank you for being there when a brother had nowhere to turn too. You were there, and I'm feeling like, yeah. And everybody says, yeah. We spread love like, yeah. I wanna say thank you for holding on when a brother was down and out. Now I feel so